guys, this is Alara. Today I'm going to talk about how a mass spectrometer works, what it does, what a stick diagram is, and how a mass spectrometer is related to carbon-12 scale. First of all, I'm going to talk about each step in a mass spectrometer and show them in a model I made with my friends. Vaporization is the first step in a mass spectrometer. The atoms go into the mass spectrometer and get vaporized to produce gaseous atoms and molecules. After vaporization, the second step is ionization. In this step, the atoms go into the ionization chamber and the electrons and positive ions get separated. As you can see in this picture of the model, the atoms come to the ionization chamber. They get heated where the paper clip and the rubber bands are. The heat separates the positive ions and the electrons. Positive ions go to the third step, acceleration, while the electrons leave the mass spectrometer. In the third step, acceleration, the ions accelerate so that they all have the same kinetic energy. After acceleration, the fourth step, deflection, will come. In this step, the positive ions are deflected into magnetic field. Deflection helps positive ions to go through the curve, which you won't be able to see in our model because of the material used. We can think of this reflection step like a hairdryer. So when a light ion comes, a hairdryer blows it far away. When a heavy ion comes, the hairdryer cannot really blow it away. Because of this, in a mass spectrometer, really heavy and a really light ions usually get stuck in the reflection step. Now we can say that the amount of deflection depends on the weight of the ion. It also depends on the number of positive charges on the ion, which also includes how many electrons were knocked off in the ionization chamber. So the more ions charged, the more ions will get deflected. After deflection, the positive ions go to the last step, which is detection. It works with the beam of ions passing through the machine. At the end of the detection step, we get the processed data as a stick diagram. So here's a stick diagram that was detected from a mass spectrometer. In this stick diagram, we can see the natural abundance and mass charge ratio. An important thing about mass charge ratio is that the smaller the mass charge ratio, the more the ion is deflected for a certain magnetic field in a mass spectrometer. Now I will talk about the calculation. As you can see in the picture, the relative atomic mass equals to the number of protons and neutrons times natural abundance divided by 100. Let's look at the example. I take the number of protons and neutrons, which is 50, in the first row and multiply it with 4.35, which is the natural abundance. Then I do the same thing for each row and get the sum of them. At the end, I divide them by 100 to find the relative atomic mass. We can also say that relative atomic mass is in comparison of carbon-12 scale, and that carbon-12 scale is used in relation to measuring the mass on a mass spectrometer. Here's a drawing of the model of a mass spectrometer where you can see the 5 steps. The first step, vaporization, then ionization, then acceleration, then deflection, and lastly detection. So that was the end of my video. I hope you enjoyed it and get a lot of ideas about the mass spectrometer. Have a nice day.